Hello guys, welcome back. Here is first question 6 we want to look at in today's class. So question 6 says a wave of has a period of 0.3 second. Using displacement time graph, show the number of cycles the wave completed in 0.6 second. And this is if the speed of the wave in question A, 6A, is 2 meters per second, calculate its wavelength. So this is the question. So how do we tackle this type of question? It says that a wave has a period of 0.6 seconds, 0.3 seconds. So question 6A. So solution. So what were we given? We're given that period. Remember, this is a question on wave. So which symbol do we use for period? That is capital letter T. So period is said to be 0.3 seconds, right? So it says using a displacement time graph, show the number of cycles. So we're looking for number of cycles the wave completed in 0.6 seconds. This 0.6 seconds is time of oscillation, right, of the wave particle. So which letter do we use for time of oscillation of the wave particle? That's small letter T. So it's always bigger than period. So take note of that. It's 0.6 seconds. So number of, it says number of cycles. We're looking for N. We're looking for N, number of cycles. So, and we have to represent this using what? Using displacement time graph. Very simple. But for us to get number of oscillation, we have this formula that N is equal to time of oscillation all over period. Simple. If you have forgotten, you can also get it from this relationship between frequency and number of oscillation. We have that frequency is equal to number of oscillation per second, right? Is that clear? So from here, we can write, since the question given to us, there's no frequency, so we can write this in terms of period, knowing fully well that period and frequency are related with this relationship, right? This formula. So which implies anywhere I see this, anywhere I see frequency, I can just put what? 1 over T. So 1 over T is something as what? N all over T. So this implies if I make, you see now, I'll still have the same thing. If I make N subject of the formula here, N will still be equal to T all over the period. Is that clear? So from here, this implies N will be equal to 0.6 all over 0.3. Is that understood? That will give us 2 number of oscillation. Is that clear? So we have gotten this, and the question said we should use displacement time graph. So remember it's wave, so we expect to have something sinusoidal, right? So just draw this, right? Just draw the vertical and horizontal, and remember that the vertical represents the displacement in meter, and the horizontal represent the time of oscillation in second. Is that clear? So this will give us, we start from the mean position to the amplitude, back to the mean position, down to the negative amplitude. So this is first oscillation. This is one cycle. So the second cycle will also go here, right? Come back to the mean position, and again to the mean position. This is second cycle. So we have shown it now. This is what we asked to show. So we have answered question what? Question 1A. So question 6A. Question 6B. In 6B, you are given that the velocity of the wave is 2 meters per second, and asked to find the wavelength, right? That's what the question says. The question says that if the speed is 2 meters per second, calculate its wavelength. So we're looking for wavelength here. So that is lambda. Lambda is not given. So what is that famous formula that we use in wave that relates the velocity, the speed, frequency, and the wavelength? So we have that V is equal to F lambda. Is that understood? Okay. V is equal to F lambda, but here we don't have frequency. From what we have just initiated here, that frequency is equal to 1 over T. So we can get our formula for our value of frequency from here, knowing our period to be 0.3. So that implies that frequency is equal to 1 all over T, which is equal to 1 all over 0.3. Is that understood? So what is 1 over 0.3? So that gives us 3.33 hertz. Is that clear? So having known our frequency, then we can get our what? Our lambda. So from here, we are given that V is 2. Just put 2 equal to frequency is 3.33 multiplied by the lambda that we are looking for. So the next thing is to divide both sides by 3.33. Is that clear? 3.33 is by 3.33. So that this, we cancel this one, then we have our lambda equal to 2 all over 3.33. So lambda will be equal to 0.6. So lambda is what? 0.66 or 0.6 meter. I hope this is understood. So this is how to tackle this type of question. It's very, very simple. Thank you for your time. See you in the next class.